Hello, wonderful people. Here we are, Chapter 7, Momentum. We're going to do Section 7.4, the Law of Conservation of Momentum today. Good news, this is going to be a very short PowerPoint. So first, a bit of review. What is momentum? The product of mass and velocity, and it's a vector quantity. The law of conservation of momentum. This will be in your notes. The total momentum of any system of objects remains constant so long as there are no outside forces acting on them. So, if you have a collision, say between a couple pool balls on a pool table, if you take the initial momentum before and after the collision, those total momentums are going to be equal. Let's talk a bit about that. Momentum is conserved, so that means that momentum in a specific direction before a collision is equal to the momentum in that same direction after the collision. Now, we can usually break that up into x and y components. Let's just take a quick look at this. There's two pucks at the right. In this first collision, momentum is conserved because the first puck completely stops and the second one departs with the same momentum as the first and in the same direction. So there it goes. That makes sense, yes? In the second collision, momentum is conserved because both pucks move off at half the speed of the first puck because they stick together. So there, again, momentum is conserved. Why isn't momentum conserved in this picture? So let's do that again. If I just showed you that in a movie, you would know something's wrong. What is wrong? The forward, we'll stay with up. The puck is moving up, and then the second puck moves sideways. So what stopped the direction going up for the puck? And what started the sideways direction for the puck? You can see that these are two separate things, so clearly you're not seeing everything that's going on. Are you with me there? The second puck moved with the same speed but in a different direction, which is exactly correct, yes. So momentum was not conserved, and as I said, you can see with your own eyes this is not making sense. So, yeah, that's the one I want. So we have momentum, total initial momentum equals total final momentum. These are the equations below the green box. We abbreviate momentum with a P, and I for initial, F for final. Now, the total momentum of the system, if we're talking about two different objects that come together and collide and then go off in two separate directions, the object number 1 and 2. So object number 1 has an initial momentum and a final momentum, and same for object number 2. That's the third equation down. Now, I can substitute P equals mv, so now I have m1 v1 for the initial conditions, m2 v2. So all I did was break that down so that now you can see all four things clearly labeled. The initial momentum of object 1, 2, then final momentum of objects 1 and 2. Okay, that's good enough for the notes for today. And then I have another PowerPoint where I explain two problems in long, glorious detail so that any homework that you have from this will be caught in those two explanations. Okay, good to go. Have a great day.